All right, we are looking at chapter 19. Chapter 19 is all about special reactions that are called redox reactions. Redox reaction stands for reduction and oxidation. Remember, a redox reaction is when there is a transfer of electrons from something to something else. Okay? Something is going to lose electrons and something else is going to gain electrons. If you ever get confused, which is which, oxidation is always losing electrons. Oxidation is losing. Reduction is gaining electrons. Reduction is gaining. For oxidation, the oxidation number will go up of a particular element, comparing it on the left side and the right side of your reaction. For reduction, the oxidation number will go down. Okay? So oxidation means it's going to lose electrons. Losing negative electrons increases its oxidation number. Reduction means it's gaining electrons, negative electrons, so its oxidation number is going to go down. Okay? You will have the rules for assigning oxidation numbers. I'll give those to you, but you have to be able to use them. So you might want to look back at them and just make sure you understand what they're saying and practice a few times of assigning the oxidation numbers. Okay? Half reactions, you have to know that oxidation and reduction always happen hand in hand. They don't happen in isolation. So half of the redox reaction is oxidation, half of the redox reaction is reduction. So we can split the redox reaction into those two half reactions. And balancing redox reaction in acidic solution, and I might add we also talked about it in basic solution. Okay? So let me do one of these here. Balance uses the following redox reaction, unless stated otherwise, assume that reaction is an acidic. Okay? I'll do one of these here, and then you can do the others and check your answers down below. So let's walk through. I'm going to do 578, I think. Yep. So I'm going to first assign oxidation numbers. So O is always a -2. There are 2 of them, so that's a total of -4. Along with the S, it would have to add up to a total of 0 because that's a neutral molecule. So S must be a +4. Br, all by itself, an element, is going to be 0. H2O, O is a -2, H is a +1. HBr, Br, H is a +1, so Br must be a -1. And H is a +1, there are 2 of them. O is a -2, there are 4 of them. So that S right there is going to be, I believe, a 6, if I'm not mistaken. Okay? So now we look at any changes. Well, the S went from 4 up to 6, so it is being oxidized. And the Br is going from 0 to -1, so it is being reduced. So I'm going to write the 2 half reactions, and then I'm going to look at them separately, balance them separately, and then bring them back together. So I'm only going to take the species that have the particular element in them that is being oxidized or reduced. Okay? So let's take the one that's being oxidized here, SO2, because it has an S in it, and on the other side we have the H2SO4. And here we got the Br2 and HBr. So don't worry about the water. That'll appear later on when we balance everything, because it doesn't have anything that's being oxidized or reduced anyways. So how do we balance this? First we have to balance all the elements except for oxygen and hydrogen. So there's 1 S on both sides. Check. Next, do the oxygen. There are 2 on the left, 4 on the right. So I do that. I balance oxygens by adding water. So I'm going to add 2 waters. Now I balance the H's. I do that by adding H+. I've got a total of 4 H's on the left, 2 over here, so I have to add 2 H pluses over on this side. Then we would balance the charge. So over on the left side, all of these are neutral, so that's 0 charge. Over on the right, the H2SO4 is neutral, but there are 2 1 pluses here on the H, so 2 of those, so it's 2+. I add electrons here to balance the charge. So I'm going to add 2 electrons here to bring this right side charge down to match the left side charge. Br, and there's only one Br on this side. So let's balance that by putting a 2. I balance the Brs. Next I would balance oxygen, but there is none. Then I balance the H's. So there are 2 there, so I'm going to add 2H plus on this side. Now I got to do charge. On the left side, I have a total of 2 plus. So that's a 2 plus here, 0 on the right. So I have to add 2 electrons here in order to balance the charges. Next thing, and before you bring these two together, you've got to make sure that you're you're losing and gaining the same number of electrons. In this case, we are. But if you're not, you've got to multiply one or both of the equations by numbers so that this number and this number of electrons is exactly equal. And therefore, you might have to you multiply everything in that equation by whatever number you are multiplying by, okay? So I don't have to worry about that. So I know that the same are lost as gained. And I'm not going to write the electrons in the final equation. So I don't have to worry about that. And I'm just going to bring all of my reactants together. And all of my products together. Okay, so I think I got everything there. Oh, also, notice that anything that is the same on both sides, I can basically cancel out. So really, I don't need the 2H plus there, 2H plus there. If I had 3H plus on one side and 4H plus on the other side, I would cancel 3 on both sides. So just reduce anything that is redundant, okay? It looks like I only have water on one side, and that would be my final equation right there, okay? Now, I'm going to add one last thing. If this was in a basic solution, then you would have to cancel any H pluses. We don't have them, but you would cancel any H pluses by adding the same number of hydroxides. Okay, so let's imagine that this 2H plus wasn't there, and you do indeed have 2H plus over here. I would have to add 2 OH negative to cancel this, and I'd have to add it to the other side as well to balance it. These 2H pluses and 2 OH negatives would turn into 2 waters, and you would add it to the 2 waters that are already there. Then you would have OHs on that side. Now you have it balanced in a basic solution. That's the only difference. You do everything the same, but at the end, if it says basic solution, you would have to cancel out the H pluses using hydroxides, turn those H pluses and hydroxides into water, and make sure you add the same number of hydroxides on the other side, okay? So your job now is to balance the rest of these and check your answers here below and ask questions, okay? I'm happy to help. I want to help, and you got to let me know if you don't understand something so that we can get you prepared for the final exam, okay?